Hello and welcome to the wonderful world of Algebra 2. So what we're going to do today is we're going to begin our linear equations unit. You'll notice we have 4 sections before we have a mid-unit test. So let's get a rockin' and a rollin'. So linear equations, what are they? What is a line? What does it look like? Well, often if you ask students, right, a line kind of looks like this, right? It goes on and on forever in both directions. So we would call that infinite. Also, it's always a straight line, right? Something we want to consider is that it's always straight. Let's look at some of our other questions, like what is an x-intercept? What is a y-intercept? What is a slope? Well, before we kind of get to those, let's go over here to our graph and graph what is called the line y equals x, or our parent function for a linear equation. Sometimes we replace y with f of x. They mean the exact same thing. So if I want to graph the line y equals x, I'm going to think of some coordinate points that have both the same x and y coordinate. So for instance, 0, 0, that has both the same x and y coordinate. 1, 1, 2, 2. Hopefully you can kind of see the point here. -1, -1. This is a 2, kind of looks a little funky. So these are all points that are on the line y equals x, because both the x coordinate and the y coordinate are the same. So if I go ahead and plot some of these points, right, you'll start to kind of see the line take shape. Go ahead, give it your best shot drawing a straight line. You may want to use a ruler. So this is our parent function of a linear equation. And what we're going to do is we're going to transform it as we go through this unit. We're going to move it up, we're going to move it down, we're going to make it steeper, we're going to make it flatter, we're going to do all of those things. So let's talk about what is an x-intercept. Well, it's a coordinate point, right? We always want to think about it in terms of the fact that it is a point where the function, and we like to use the word function instead of line because we're not always going to be working with lines this semester, where the function crosses the x-axis. So in this case, my x-intercept would be the coordinate point 0, 0, because that's where it's crossing the x-axis. That goes hand in hand with a y-intercept. That is the point where the function crosses the y-axis. Right? And remember, our y-axis goes up and down, right? This is my y-axis, this is my x-axis. So when I look at our parent function y equals x, well, our y-intercept is the same thing. It is the point 0, 0. Now, slope is something that comes up quite a bit, right? Slope is probably something that you remember from both Algebra 1 and geometry. We cover it quite a lot. It will definitely be a question on the ACT. So slope is the steepness. How steep is your line? And we like to think of things like, well, if it's going up, right, we read left to right. So if you see a line going up, then that's going to have a positive slope. If you see a line that's going down as you read from left to right, then that's a negatively sloped line. Always think of that in the back of your mind, especially when you start calculating slope values. How do we calculate slope? Right? So how do we calculate slope? Some of you might remember that slope we will identify as m. M stands for slope. And it really comes from the French word monter, which means slope or mountain. And of course, you know, we haven't changed the letter, so we're going to stick with m. M equals slope, which sometimes students remember as rise over run, right? If you want to kind of count your rise over your run between 2 points. Also, the algebraic calculation is y2 minus y1 over x2 minus x1. So let's look at our parent function. What is our slope? Well, my rise, say I'm going from this point to this point, my rise is up 1 and my run is to the right 1. So therefore, my slope for this particular equation, my parent function, is just 1 over 1, which is equal to 1. So why are linear equations so important? Why do we talk about them so much? Why do we cover them in Algebra 1 and Algebra 2 and geometry? Well, because they're found in everyday life, right? Think about someone who has a job and they make 10 bucks an hour. If we want to figure out how much money they'll make after working 6 hours, we just do 6 times 10. Well, that's really the equation, y equals 10x, right? Their 10 represents how much they make an hour, and x is the input, or the number of hours they work, and the output is how much you make for that time. So I encourage you to think of a linear relationship you find in everyday life that isn't just hourly wages, and discuss this with someone nearby. ACT checkpoint, right? There will be ACT questions that consist of a linear relationship. Here's an ACT question that was on an ACT 2 years ago, and it asks about a linear relationship between time t and velocity v. I encourage you to pause the video right now and try this question on your own before I give you the answer. The answer to this question is B, because at time 0, my y-intercept was 120. My slope, well, how much is this going up? From here to here? 32. How about from here to here? 32. So my change, or my slope, is 32. So therefore, that goes in the m part of y equals mx plus b. And it's okay if you didn't get that question right. The goal of this unit is to make sure that when you see these questions on the ACT, you will get them right. Now, with that said, a lot of times students are able to get these just by using their kind of previous knowledge or by doing a great job of guessing and checking. So let's do a little bit of a geometry review, really not that much, but I do want to make sure that we understand some of these geometric words like translate and reflect and all that kind of stuff. So what we're going to do is we're going to plot the point A, which is at -2, +3. So here's our A value. Now, what I'd like you to do is translate this 1 unit left. So I'm going to move it over here. Now, what is our new point for A prime? Well, it's -3, 3. Now let's go back here to my A value, and this time I want to reflect it across the x-axis. Right? So my x-axis is right down here, and a reflection is really a mirror. So I'm going to mirror this point, but now it's going to be on the other side of the x-axis. So here's this A prime. What is the value of this A prime? Right? It's -2, -3. Let's go back to our A value, and now we're going to reflect it over the y-axis. Here's my y-axis. So if I reflect this across the y-axis, I get 2, 3. And then last but not least, if I come up here, and I'm going to translate the 6 units down. 1, 2, 3, 4, 5, 6. Oh, same exact location. I wind up with -2, -3. So translate really just means to move, whereas reflect, you're mirroring over a particular line. All right, let's talk about how we can find some x-intercepts and some y-intercepts. So the first thing I notice about all of these equations that I have written in front of me is that they're in what we call slope-intercept form, and we'll get to that. That tells me that my slope, we already talked about that, that's the m value. Now, what is this b value? This b value stands for the y-intercept. So because of that, I know that all of these values here, because it's in this format, represent the y-intercept. But remember, it is a point. It is a coordinate point. Therefore, you need to make sure you write it as a coordinate point. So up here, the y-intercept is at 0, -4. Here, it's at 0, 12, and down here it's at 0, 4.8, right? These are all on the y-axis, and they represent the y-intercepts of these functions. Now, how do we find the x-intercept? Well, let's think about that for a second. Say I have a linear equation, and it's right here, right? This is my x-intercept. Let's say this point is -2, 0. Now maybe I have another line, and here's this x-intercept. Say this one is at 3, 0. What do you notice about both of these x-intercepts? What do they have in common? Well, for both of them, for an x-intercept, the y value is always equal to 0. So if I want to algebraically solve for the x-intercept, I simply make y equal to 0. Now I must remember how to solve these, right? Just getting some practice with our algebra, some two-step equations. I want to isolate the 8x, so I add 4 to both sides. And then I divide by 8. So I wind up with x is equal to 4/8, and I am going to simplify that down. It is 1/2. And remember, it's a coordinate point, so it should have both x value and y value. Let's do this next one. I'm going to set y equal to 0. Now, using your algebraic skills and knowing what you're solving for, right? I want to solve for positive x. I know normally we'd say, well, subtract 12, divide by -1, but I see a shortcut. You guys are in Algebra 2 now. I think you can handle some of these shortcuts, right? Use those rules of algebra to shorten some of these steps. I can solve just right away by saying, all right, my x value is equal to 12. I encourage you to pause the video now and try letter C on your own. Solve this. Within the Algebra 2 classroom, we always have access to our calculators, so feel free to always use the calculator that you have on your iPad or in front of you on my graphing calculator. All right, so we just went ahead and solved our x-intercepts and y-intercepts, but what if my equation is not in y equals mx plus b form? What if I need to find my y-intercept without relying on y equals mx plus b? Well, the same way that for my x-intercept, right, these two were tied together, x-intercept, y equals 0. Well, for a y-intercept, you're always going to have x equal to 0. So you could always have plugged that in as well, right? If I change my x value to 0, I get 8 times 0 minus 4, y is equal to -4. That's another way that you can find a y-intercept algebraically. Let's move on to our last thing of today is us calculating slope, right? We want to be able to calculate the slope between these 2 points, and we are going to use our slope formula y2 minus y1 over x2 minus x1. The first thing I highly recommend you do is you label these coordinate points. And then you slowly take your time setting up your equation. -4 minus 5 over -9 minus 0. I get -4 minus 5. Do not make any integer errors. Feel free to use the calculator to make sure that you don't make those errors. The slope for my first one is 1. I encourage you to pause the video and try the others on your own before I go ahead and show you the work. All right, so there are 3 examples of calculating the slope and finding the slope. This concludes kind of our introduction into Algebra 2. You can go ahead and complete the 1.0 worksheet. Use these notes as a good guide for that worksheet.